everyone! Welcome to another installment of Kidding Around. My name is Melanie Smith and today is Test Tube Tuesday. As you know, we do all things scientific on these days, and today we're going to talk about compasses. Do you know what a compass is? Before we go too deep into that, I want to ask you another question. I want you to imagine yourself out stranded in a forest, lost and trying to get home. What would you need to get home? Some people might say a map, some people might say a compass, some people might say good hiking shoes, and truly the answer is that all three would help you. We can't do too much about the hiking shoes right here, but we are going to talk about the first two. All right, so what we need first, what we said, was a map, right? So here's a map of a national park that's close to my home, and I'm going to pretend that I am down here somewhere, and I am trying to get here somewhere. So I have my map, and I know relatively close to where I am, and I know where I want to go, but I don't know which direction I'm facing. On maps, we have cardinal directions that we follow, and normally on maps, the top is north, the bottom is south, the left is west, and the right is east. You might see some maps that there's an indication that that's not always the case, but if you don't see an indication, you can trust that it's north, south, west, and east. So I know that I want to go north, but I don't know where north is. So what I do is I pull out my handy dandy phone and I open my compass app, and it tells me which way north is. So I now know that I need to go that way if I were in the park, and it would eventually get me up to the place that I want to go. So that's great, but we also realize that phones have not been around forever. I know they have been around for all of your life, but in the grand scheme of things, they're a pretty new invention. We know that sailors and explorers 100 years ago didn't just pull out their phone and open their compass map to know which way to go. So how did they know? Well, they used a compass, which was another thing that we talked about to help you get out of the forest. And theirs looked a little bit more like this. Obviously, this is made of plastic, and this is a relatively new compass. So they wouldn't probably have used this 100 years ago, but the general principle is the same. There's a pointer in there, a needle, that's pointing one way, and then there's some liquid in there, and it's telling us that that way is north. And in fact, that is the way that my phone said north was. So it's good that they agree. I'm glad that they agree that that's the way north is. So that helps me get out of the forest. But how does a compass work? How does it know which way north is? Well, to get to that, we need to first talk about magnets. I'm sure that most of you know what magnets are. You probably even have some on your refrigerator. They can help hang papers or notes or important notices. Our refrigerator is always full of papers held by magnets. If you've ever played with magnets, you probably know that sometimes they attract each other. Sometimes they really want to be next to each other, like that one that just flipped into my hand. And sometimes they really don't want to be with each other. Hold on, I'm magnetized right now. Welcome to Science in Action. All right. So sometimes they kind of move away from each other. Isn't that interesting? Do you see how I'm controlling that magnet by not even touching it? So that is repelling. This magnet is repelling this one. And the reason that happens is because all magnets have two sides, and we call those poles. One's a positive pole and one is a negative pole. And if they are repelling like this, it means their two poles are the same that are facing each other. So this one, we're going to pretend it's negative. I don't know if it's negative or positive. It doesn't matter. It means that they're the same. So if this one's negative, then this one is clearly negative because it's moving it away. Magnets can also attract each other, and the way that they do that is if they've got two different poles facing each other. So now I flipped this one over. I don't know if you saw that. See, it's repelling. Now I'm going to flip it over. And so now the poles are going to be, one's positive and one's negative. So they attract each other, just like that. So if you've heard the phrase opposites attract, that can help you know, that can help you remember how magnets work too. Positive and negative attract, positive and positive repel, or negative and negative repel. So there's a little interesting tidbit. So then how do magnets and compasses work? Well, here's the deal. There's a magnet in the compass. And so it is reacting to another magnet. Do you know what magnet it's reacting to? Would you believe it if I told you that the Earth, the big globe that we live on, is a magnet? And so this is reacting to the Earth's magnetic field, and it is being pulled to keep pointing north. Kind of interesting. So we're going to see today if we can make our own magnet, kind of along the same lines as this. We'll have some liquid, we'll have a needle, and we'll have a magnet. What you're going to need for this is a bowl of water, a cork. These are sometimes used in wine bottles or olive oil bottles, and we're going to cut that cork down to just about a half an inch, maybe between a quarter of an inch and a half an inch disc. This is going to be the flotation device. And then we also need a needle. Here, I'm pulling a brand new needle out of the package. And we need some magnets, and we need a Sharpie, and we need some tape. I think you can probably see that all. All right, so we have the needle, and so our needle is going to act like the needle of the compass here. To do that, to make sure that it can float, because the needle sinks on its own, to make sure that the needle can float, we're going to put it on this cork, which is buoyant. You can see right there it floats. All right, and we are going to tape it, and we're going to see if it will point north. So I'm just going to tape it just so it stays on. There's nothing magic to the tape. And we're going to put it in and see what it does. We'll let it kind of find its way. Kind of spins around. It wouldn't say that it's pointing anywhere like this needle is, would you? All right, so we're going to do some magic, also known as science, and we're going to make this needle magnetic. Did you know that rubbing magnets on a piece of metal can often make it magnetic? Sometimes I've heard of people doing this with their screwdrivers. They rub magnets along the long metal part of their screwdrivers so that it's easier, so that the screws kind of stick in when you're trying to screw in, so you're not always losing screws. Kind of an interesting thing. So we're going to do the same exact thing with our needle. We're going to magnetize it, so I'm going to take these magnets and I'm going to run them along this needle. I'm going to run them all the same way. As we were talking about, magnets definitely have directional pull, so we want to make sure that we're not confusing the magnet. And we are going to rub this for 30 or 35 times, all the same way. Remember, no scrubbing, just one way, all the same way, for 30 or 35 times. I have to tell you, as I'm talking, I have not been counting, so I'm going to probably overdo it to make sure that this works. So I'll do it 10 more times. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And 1 for good luck. All right. I'm going to tape it now to the cork to keep it buoyant, remember, so it floats just like our compass there does. I'm going to tape it to make sure that it sticks, to make sure it stays on top. All right, and then I put it in the water, and let's see if we can make this point north. Let's get it in the middle of the water there. Well, it looks like to me it's pretty clearly pointing north. Let's give it a spin and see if it spins around. It absolutely does. Did you see that? I'll spin it again so you can see. Oh, there, that was really good. It really shows you how it swings back, and sometimes it kind of bumps the bowl, but when it kind of settles, you can tell that it heads north. I wish I could get it in the middle to just stop moving so you could see how it swings that way. It is clearly pointing north, just the way this other compass is, just the way my phone did. So good. Everybody's in agreement that that way is north, and that's the way home, right? So once you have north and you know for sure that it's pointing north, you can take your Sharpie and then you can mark that edge so you know that you are pointing north. And here, let's put it in this way and make sure it flips around. One final test, right? Science is all about testing and retesting and verifying and re-verifying. And there we go, we have north. In fact, speaking of that testing and retesting, I have a funny story for you. As I was setting up this experiment, this is an experiment that I've done several times, and I know that it works. I know that it works. So as I was testing it, just making sure that it all worked, you know, this time, doing it this time again, I was using some other needles, and I couldn't figure out why. I was doing my control to see if it would point, you know, to see if it would point one way or the other before I magnetized it. And the eyes of the needles kept pointing north, even before I had magnetized them. And I couldn't figure out why. And I was really struggling. I was about to scrap this science experiment for today because I couldn't figure out why it wasn't working, and it had always worked in the past. I was talking to my husband about it, and he said, well, that doesn't really make sense. Do you just buy magnetized needles? Which seems a little silly. I don't know why needles would need to be magnetized. And then he said, oh, do you happen to store them in a magnetic container? And I thought, oh my goodness, yes, I do. This is the way I store my needles. And this little green thing is a magnet, so it holds them in when you pull them out like that so they don't fall all over your floor, because as you can imagine, a sharp needle falling on your floor and you not knowing about it would be really bad. You could walk on it. So anyway, there we go. I think this is a perfect example of how science doesn't always work the way we think that it will, and it's really important to ask why it's not working the way we think it will, and retest and figure out if there's something different that we could try another way, try another thing. Absolutely. That's really important about science. Science is not just doing an experiment and getting a result. It's about testing, and if you don't get the results you think you'll get, asking why, and if you do get the results you think you will, ask why, and ask if there's any variation that would change that. So anyway, that's a real life lesson about compasses and finding north. All of the needles in here find north without being magnetized because in effect they already are magnetized just by the way that they're stored. Kind of a funny little story. Well, I hope that your compasses are all pointing north, and if they're not, I hope you're asking why and seeing if you can change it so that they will point north. I would love to see videos of your compasses. Your parents can upload them to our Facebook page. I would love to see your science in action.